Okay, so now on to looking at the intervals that a function is increasing, decreasing, or constant. So when looking at the graph, it was, kind of basic. When the graph is going up, it's increasing. When the graph is going down, it's decreasing. And when it remains the same, it's constant. But looking at the equation is sometimes not always easy to be able to understand what's really going on, with the equation. So what I did is, I just kind of provided 3 equations that we can kind of look at and kind of look at the graph to be able to identify the intervals. Now, again, it's important to understand that when we're identifying the intervals that a function is increasing, decreasing, or constant, we're observing the y values to tell us if the graph is going up or down, but we are going to describe those intervals only using the x values, not the y values. And that's why I wanted to, create a video like this, so therefore you can see the basic differences here. All right, so let's go and look at example number 3, which I opened all these up for you. All right, so the first example here, we can see that we have this equation, and it looks like, as you read this graph from left to right here, the graph is, as I'm looking, again, you're reading it, you're reading the x values from left to right, and then you're observing what is the graph doing. So from the left, it looks like the graph is going down, all the way down to -1. Then from the x interval of -1 to 1, the graph is remaining the same. And then from the interval from 1 all the way to infinity, right, because this graph doesn't look like it's stopping, the graph is going to continue increasing, okay? So the way that we would just kind of write that is, let's go and use purple. So we can say that the graph is, let's go and do decreasing first. Let's zoom in. So the graph is decreasing on the interval of -infinity to -1. It's constant on the interval from -1 to 1. And again, I'm using open parentheses because, technically at that point, it can't be, at the point like -1, it can't be decreasing and constant at the exact same point. So we're using the open interval. So therefore, we're not like cross-defining the values. And then we can say that the graph is increasing on the interval 1 to infinity. All right, so let's go and look at the next one here, which is a polynomial, which we'll talk about again. So looking at the polynomial, let's see. Okay, post back up. So now we can look at this, and let's look at this next equation, polynomial. Boom. Okay, now I like this equation because obviously this is one that you can easily graph like in a graphing calculator. And I prefer Desmos working on this one just because it's so easy to find these absolute maximums and absolute minimums rather than having to use graphing technology. But you could use graphing technology, a TI calculator or Casio or whatever you use to find those values. But once you find those values, it's very important to remember that we are looking to extract only the x values, right? So we can see from -infinity to -0.466, the graph is increasing. The y value is just telling us like how high that point is going, but that's not going to be how we're going to describe the increasing, decreasing intervals. So in that graph, it was increasing to decreasing and then increasing back again. So let's go ahead and write the intervals increasing first. So it was increasing. Now, I wrote these down because I was like, I'm not going to remember these. So it's increasing from -infinity to -0.466. Then I'm going to use a union symbol. And then it was also increasing on the interval 0.716 to infinity. That looks really bad. Sorry about that. And it was only in decreasing, if you remember. Let's look back at it again. Right? So it's increasing from -infinity to -4.66, and then it's increasing from 0.716 to infinity. And then it's decreasing from -0.466 to 0.716. So therefore, we can say that it's decreasing on the interval -0.466 to the interval 0.716. Okay. Again, you don't need to use the union symbol, but I think that it sometimes kind of helps. All right, the last example is a piecewise function. You can see again that we have a function that is defined for 3 different functions. We have a quadratic, an absolute value, and then a constant. And basically what you could probably go ahead and define, if you know what these graphs look like, you could probably define the increasing, decreasing values just by looking at this piecewise function. But I know that's not something that many people might be as comfortable with. So I wrote them all out as piecewise functions so we can look at them all together. All right. Now, in this case, you can see here we have the quadratic, and then we have the linear equation, and then we have the constant. Now, it's important to kind of note that the Desmos is not really giving us an accurate answer. It's giving like 1.22, or it's getting close. Here, I'm trying to get really close, and it's kind of hard, but you can see at 1, it's should be undefined. At 1, it's defined for that. I'm not sure why that's giving me that, because it should be defined for there. I guess it depends on the function. But sometimes you can get a little bit difficult. You can get like really close to there, and it won't be able to find the value, or it'll have a rounding error. So just be aware of that. But we can see that the graph is decreasing from -infinity to 1. It's increasing from 1 to 2, and then it's constant from 2 to infinity. So we're just going to go ahead and write that down. I think I can remember all that, hopefully. Let's go and check it out. So let's say it was decreasing first. So we'll write decreasing from -infinity to +1. It was increasing from +1 to 2. And then it was constant from 2 to infinity. And again, this is a good descriptor of the x values. At each of those intervals, we can say that the graph is going, I didn't do this before, graph is going down. On the interval 1 to 2, the graph is going up. On the interval 2 to infinity, the graph is constant. So when we're describing these intervals, again, I just want to write this in there. When we're describing these intervals, we're not describing how high or how low or what values stay the same. We're just describing it's going down on this interval from -infinity to 1. It's going up from 1 to 2. And it's remaining the same from 2 to infinity. So there you go, ladies and gentlemen. That is how you describe the constant intervals when given an equation.